Hello, Jeff here with the Dominus Galaxia update for December. Coming in a little bit late at December. Sorry about that, but happy belated Christmas and happy New Year, everybody. What I was thinking that I was going to work on was the neutrals and diplomacy, and what I actually ended up working on is some rendering features and a migration from the built-in Unity pipeline, which is the old crusty old one, to the universal rendering pipeline, which is the new thing. And this is it's a little bit ironic because I've sort of started that process probably a half dozen times in the past, and each time ran into big roadblocks, threw my hands up in the air, and just went back to whatever I was doing before. Despite that, when I first started work at my job on the drilling simulator, my first job was migrating that from the built-in rendering pipeline to URP. It wasn't just me, but I was spearheading that, and that's just because I said the words. I just said that I was interested in URP or something in the interview, and all of a sudden they decided, I was gonna migrate them to URP, and that was actually pretty straightforward. But that project didn't do some of the funky things that Dominus Galaxia does that makes it more difficult in Dominus Galaxia's case. So some things like this Fog of War, where you have the stars outside and inside, and they're sort of in front and behind certain elements at the same time, or the fuel range circles when you have a whole bunch of planets and they combine and they share the same alpha sort of monolithically for everything, and a whole bunch of issues besides those. So there's lots of custom work to redo, but this time I went in and I thought, just for the heck of it, gave it another go, and by the end of the day, I had gone past a number of roadblocks that before had stopped me. So I've been continuing with that, and the benefit will be, the most immediate thing is that the frame rate seems like it should be about double. It might be a bit lower. It could be quite a bit higher. It really depends on a number of things. But if I don't change much, it should be about double, and that's more at the higher resolutions. A bit less benefit at lower resolutions. The higher that you go, the more benefit you get. But that will help the game run on lower end hardware. But the universal rendering pipeline also has a bunch of features like the visual effects graph, which is just particle systems on steroids that you can make these really beautiful effects, and it's more forward looking and future proof. And my hope is that I can bump up the quality of the game a little bit and make it more visually cohesive. So we have not this background necessarily. This isn't my favorite background, but some of the backgrounds are actually really, really nice looking in Dominus Galaxia. But then you have like this foreground that it sort of feels like it's just sort of plastered over top of it, and to me it's never really felt that cohesive. You can't. Not in this screen, but if you have like a bunch of nebula over Sol would just be floating on top of it. And there's a whole bunch of things that visually that I'd like to try to improve. And my goal for all of this is to have that build with the new rendering pipeline migration done for the end of January. And for me, that seems like a pretty... that's a date that I definitely want to hit. I don't want to take too long on this. I want to definitely get back to the gameplay stuff and the neutrals and the diplomacy, because I think that I have some really good ideas there and I want to see how they pan out. Anyway, so one of the aspects that I'm going to touch on that's one of the more awkward things to migrate is the UI blur, this Gaussian blur. So in the current build, which is what we're showing here, we're using this really ancient, old, deprecated middleware asset from the asset store that's no longer on sale. But this goes way back to the very beginning of the beginning of the project, and I was not nearly as strong of a developer at the time. But this system, basically, for each one of these little blur areas, it creates a new camera. That camera looks at everything, but it's but the rect is only as large as the blur. So the camera for this little element is just that big, and it sees everything underneath of it, and then it applies post-process image effect onto that camera. So that's really flexible. So you can have different elements that have different blurs. You're not paying a huge tax if you only have a very small element, because you aren't needing to blur the entire screen. And you can do things like in the design screen here, if I do add new weapon, you see that there's just this really subtle blur in the background. And it's going over top of all of the other... Oh yeah, and then there's this heavier blur on here that's over top. So you basically have three stacks of blur. You have the blur that's going on for these panels. Then you have that blur that goes over top of it, and then you have the blur from the panel that's over top of that. And that's a little bit overkill, but it's cool. Certainly not good for performance on lower end systems. So yeah, the blur is one of the bigger blockers for getting the game to run well on low end systems. And that's just because creating cameras are expensive. You really don't want to be creating too many cameras. It's not like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for that scene. Not that great. In any case, there's a newer asset on the asset store that I think I've kind of started migrating a little bit to years ago, and that's what this screen is actually using. So there's two different solutions, but the issue is that this newer one, and I think it's one of the, if not the most popular thing on the asset store, is that it's not that flexible. It's the setup is a pain, because you basically have to, it needs its own game object, then you put the UI on, you have to put the UI on top of that one, and that means basically in terms of the main stuff for Dominus Galaxia, rearranging basically all of the UIs and adding more game objects, so that's a bit heavier. And, well, there's a bunch of intangible reasons that I don't like the solution that much that I won't get into. One is that it says that it will take into account the resolution of the screen when it blurs, but I don't think it actually does. But yeah, it's hard to see on this screen, but I think I've done tests where it doesn't do that. But yeah, this solution blurs the entire screen, and then the elements that use the blur just grab that. So we're blurring here, here, and here, but we're paying the cost for the entire screen. And all these blurs have to be the same because they're all just grabbing from the same render texture. Anyway, so what I've decided to do, and this has been my back half of December, is I decided I'd come up with my own system. And this is Gaussian blur is one of the simplest image effects that, in theory, that you have tons of tutorials for on YouTube, and you'd think it'd be quick, but I kind of decided to do this in a different way. So what I actually came up with was a really novel implementation, novel enough that if anybody else is using it, nobody's mentioned it online in any form that I'm able to search. That said, I wouldn't be surprised if somebody else has done this. Hello, kitty. I wouldn't be surprised if somebody has done this. But what I'm doing is I'm leveraging compute shaders for their ability to dispatch more arbitrary data to them. So I don't need to send the entire screen. Or to be fair, you could with normal shaders you could probably send a portion of the screen, like some sort of square rect, but then you wouldn't be able to send one here, 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 etc. You'd just be able to send either everything or just a portion. But with the compute shader, it's very interesting. Overall, like, it's a bit slower, everything else being equal, but it gives a lot of flexibility. It takes some flexibility away, but the performance implications are really interesting, and for the vast majority of situations, I think this is just a far superior approach. So we're talking a lot and we aren't showing much off, so let's create a new canvas here. And we're screen space overlay, which basically means that our UI is just going to be this orthographic perspective that overlays the main, overlays pretty much everything, but we'll create an image, and I'll add a canvas group and a UI blur component. And this is what I am working on. It's pretty much ready to rumble. There's probably a bit of bug fixing, a bit of polish, 2 days left before I just migrate Dominus Galaxia over. But let's see. Okay, so let's just blur, fade that out. We'll add a bit of color so we can see the area. If we disable the UI blur, yeah, we can change the height, width. So yeah, we can enable the UI blur, and yeah, we see this little blur, but we have a whole bunch of different things, knobs and dials that we can play with. So this is a true Gaussian implementation. It's not a box blur that's doing several iterations to approximate Gaussian blur. And the main reason for that is just because, yeah, we talked about compute shaders and there being limitations, and the way that I'm doing this with just grabbing the one area, that's sort of the limitation of the approach. because you'd end up getting artifacts around the edges with a box blur that you're doing multiple iterations of, at least the way that I'm doing it. And I should mention a box blur is just you take a point and then you sample all the points around it. And that's pretty much it. So you could do like the corners or left, right, up, down, or you could do all 9 sections. And if you take that and then you do it again and do it again, it begins to approximate a Gaussian blur to the point where you basically can't tell the difference. But here what we have is we have a true Gaussian implementation, and we can change the number of samples per side. So we'd be sampling like 15 times on this side, 15 times on that side, 15 up, 15 down. We can change the distance between sample points, so that'll make it more or less blurry. And you sort of start to see, in some instances, you start to see these blocky kind of artifacts when you're trying to do too much blur with not enough. So there's an example of that. And that's not a bug, that's just not a feature either, really. It's just the nature of the beast. The other thing you could do is you can downsample the source, and if you're using a bilinear filter there with the downsampled texture, then you get a little bit of blur for free. So that's a trick that a lot of people do, and with that, then say we do 6 points per side, so we can downsample a lot, and now we have this really sort of fuzzy blur, but we don't necessarily need to pay that much performance. So we could do 6 per side and get it to the point where you don't get those blocky artifacts, but yeah, you get it the way that you want it to look. So one optimization that we can do here is we can rely on the hardware GPU filtering. And so you sort of see when you downsample how you have this fuzziness between the pixels, right? So if that's a pixel and that's a pixel, you have all these values in between it. So instead of just sampling here and here, you could just sample in between. And that effectively speeds the algorithm up by about a factor of 2. The trick here, though, is that only really works well when you aren't sampling far enough to extend past the pixel boundary. So I actually have this optimization, and I can enable it here. We aren't even doing any sort of blur yet, so we don't see anything. So if I turn it on and off, you basically don't notice a difference. If we move the sample point distance low enough, there's no difference at all, at least nothing perceptible. If we took the downsampling down, that's hard to see. With YouTube compression, you probably can't see it, but I can notice a difference. But if we go, see right there. The further out we go, the more we can notice. Now we notice a lot of difference. So downsampling makes it more lenient when you can apply that optimization because fewer pixels, so you aren't going to really cross that boundary as easily. But let's say with this, what we could do is if we have a really high-end PC and we don't care about performance, we could just do no downsampling if we want. Just take a huge amount of samples per side and just change the sample point distance to change the blur, and we get this really, really beautiful effect. I'm gonna disable that coloration there, and that's fine. But let's say we want to run on something that's super slow or on a mobile device. Then maybe we could get something really somewhat close by downsampling a ton. Take let's say 6 points per side. We'll optimize. We'll use that optimization. So now we're down to 3 points per side. And just, blur it until we can't see any of those artifacts. And now we have something that looks really good, but it's like 8 times faster-ish. More than 8 times with the optimization. So that gives me a lot of flexibility that I didn't have previously, and I'm not seeing with any of the other solutions. So one of the things that I'll be doing to finalize this system will be being able to save the settings for these elsewhere, drag and drop them. So if I want to change all of a certain type of panel at once, I can do that, and then to have different properties for different quality settings and maybe different platforms also. And blur is one of the things that just kills low-end systems with Dominus Galaxia, and with this I could basically fix that altogether. I mean, like you can get really, really cheap if you want and still have it look pretty good. Anyway, that's not really the coolest thing about the system. So we were talking before, and let me just demonstrate. Here, if I copy this image and then I move it over, and we'll give this guy color so we can tell who he is, so we can see him more easily. We'll make him yellow. Why not? So I could blur this guy independently of that guy, even though they're both working off the same camera. Nobody's creating new cameras or anything like that. We're basically writing. We're basically writing straight to the camera, and then we're rendering on top of that. That is, I haven't really seen other people do that, because you really can only do that with compute shaders, and I haven't seen anybody use this exact approach yet. So the cool thing here is if I overlay these guys, I could change the priority. So I can make it so that this blur has priority or that blur has priority. So check this out. This is pretty cool. If I take our first blur and I move him so it covers the entire screen. Oh yeah, I should mention, I can add as many images as I want here, and my draw calls stay the same. So the thing that will increase draw calls is if I downsample. Basically, every frame we sort of have this dictionary of downsampled render textures that we can grab from. So if I downsample to this guy to 10 and grab, now I'm at 16 instead of 15. If I take this guy, I downsample him to 11, I'm at 17. But if I go down to 10 again, 16, because they're sharing. So in terms of performance, you wouldn't want to have 16 different downsample settings. You just want to use one or two. But I'm getting ahead of myself. Now, let's see the cool thing. Okay, so this is pretty cool. This is a sweet effect that I will probably never use for Dominus Galaxia, but there's probably some developer out there somewhere who's thinking, oh, if only I had this effect. And this is if we give this guy priority. Oh, there we go, priority. We can create a hole in the blur. We could create multiple holes in the blur if we want. We can move that around, actually. Now, the other thing we could do here is we can fade the effect in and down. There's a few ways we could do that. The first one is, let's see. Oh, yeah. Alpha blend. So that would work if we wanted to slowly fade this guy in, which actually looks like it's fading the background blur out, that is a pretty cool effect, I think. Irrelevant for Dominus Galaxia probably, but pretty cool. I'm going to disable that guy for now and go down here. So we can do the alpha blend, which is probably what your phone does for this effect. And, basically we have the blur and we have the non-blurred image, and we just lerp between them. What is a bit nicer is we could do sample point distance. So if we have a sample point distance of, let's say, 3, then at alpha 0 up here, the actual sample point distance will be communicating to the render pass will be 0, and as we slowly go up to 1, now that looks pretty nice. However, if we heavily downsample, that doesn't really work, because as soon as we go past alpha 0, because we have we do have some optimization here, so that if something isn't going to show up, it's not going to render, so we're only paying for what we use. But the moment that it should be rendering, because we have some alpha, now all that downsample pops up, and that's a bit poppy. So the other thing we could do is we can blend both together, which is not as nice as just the sample distance, but I think it looks nicer than alpha blend by itself. Anyway, I'm talking a lot about this system, but I'm kind of proud about it, and it's kind of cool. So this is a screen space overlay canvas. So it's basically orthographic. Why isn't this guy on? Oh, right, alpha. So yeah, let's just turn you off. Okay. Let's create a new canvas, and instead of screen space overlay, we'll do screen space cameras. This basically renders to a camera. So I have this camera set up. It's a UI. It's for UI. It's just rendering UI, and it's over top of the main cam. So if we add another image here, make it bigger, call it a canvas group, and a UI blur. make it transparent. So because we're rendering to a camera now we have depth. We have perspective. So one cool thing we could do is we can change the rotation of the blur. And this works pretty good. That's something, and this is something that the original blur implementation for Dominus Galaxia, the deprecated one, that can't do. At least I don't think it can do it. Maybe it can. I don't think so though. But yeah, we can blur a plane that is at an angle, and this basically uses a different function in the compute shader that's a little bit heavier because it needs to do a bit more calculation. So basically what it does here is if it sees that it's not on an angle, it will use the regular function, and if it's on an angle, it will use a slightly heavier function, and that's seamless. So now, because this camera is rendering on top, we could actually take our old image here, apply a bit of a blur, and if we disable this UI blur, we can see that the blur underneath of it is taking an effect. However, if we enable this blur, we can see that we can also add our own blur, and these blurs are additive. So that's the exact sort of effect that we're seeing with the Ship Designer, where we had a blur adding on top of another blur, and that's something that the old kludgy system could do, but none of these new systems are very good at. Technically, some of them can do it. It's just because you only have one blur for the entire screen. If you wanted to have just a very slight blur like you saw in that shipyard, you need to make an entire camera canvas setup just for that one effect. And that would be not good for performance, elegance, or anything like that. Lastly, we could put this camera into world space. And that will also work. But in this case, I think let's see. Yeah, in this case, we're actually rendering to the SAM camera, so we don't have the additive effect. We could have an additive effect with screen space camera, but we can't with the overlay. Theoretically, maybe we could make it work, but there's no real need to, and we'd have to change the way things work a little bit. But so this system is, I think it's really, really cool. The one big thing that it's missing is the ability to mask out with a texture a portion of the blur. So if you just wanted to have a blur that was a rounded circle that's around some text, which would be a cool effect, we can't do that yet. So because this isn't just grabbing blurred pixels from the screen for the UI, but actually blurring the camera render target, and then just rendering the UI on top of that, that makes that a little bit more tricky. We need to do a projection from from 3D space to 2D space, basically, and I haven't quite figured that out. Not sure if it can even be done very cheaply with the compute shaders, but we'll have to see. But I think I'm probably going to throw this on the Unity Asset Store after I polish it up a bit, because it's really different from the other solutions there. And besides that lack of the ability to mask something out, or to mask out a texture, personally, I think it's more or less just better than the other solutions. But, of course, I'm biased, and it will depend a little bit on use case. But for me, this is just super flexible, super nice. It's not... it's not fiddly. It just works. So yeah, this is the main thing. I've been ranting about this for too long. It's a silly little project, but that's definitely the thing that is most show-offable, and I am most proud of. But hopefully by the end of January, I'll have a lot more to show off in terms of just cool rendering and presentation stuff. Anyway, you guys have a happy belated Christmas, or a merry belated Christmas, I should say, and a happy new year. I'm out.